Hi, welcome. Today's lesson is on physical and chemical properties and physical and chemical changes. These are important concepts in chemistry, so I want to make sure you understand them. Let's take a look at physical properties first. What is a physical property? Well, that's any property of matter which can be perceived, observed, or measured without changing the chemical identity of the substance. So that's a lot of words. What does all that really mean? Well, let's take a look at some examples. Here I have two petri dishes, one with some ice cubes, here they're a little cold, and one with a strip of magnesium. So what can I observe about them without changing their chemical composition? Well, water is the composition of ice, and magnesium is the composition of this metal. So H2O for the ice and magnesium for the metal. Well, what can I observe about them without changing that fact? Well, I can observe that they both are solids at room temperature. There we have a solid ice chunk, and the magnesium's a solid. They're both rectangles. They both have a color. The magnesium is a little silver, and I'd say the ice looks a little whitish in color here. So there are many things I could observe about these two materials, and they would be considered physical properties as long as they still were H2O and magnesium. So I want you to go online on the internet and look up some other physical properties, or think of some in your own head that you could observe while the materials remained their same chemical composition. So that's a physical property. What about a physical change? Well, that's any change in which the matter's physical appearance, property, or form is altered, but the chemical composition remains the same. So we need a change this time, but not a change in its chemical composition. So what about our two examples? Here we have ice, and you might not be able to see too well with the webcam, but as we've sat here for a while, the ice has actually started to change its form, but not its chemical composition, because it's melting. And so underneath these ice cubes, I have liquid water. But liquid water is still H2O, and the ice is still H2O. And you can kind of see they're kind of floating around because they're floating on water now. So that's a physical change. The water appears different than the ice cubes, but they still are made up of the chemical two hydrogen atoms and one oxygen atom, H2O. So it looks different as a liquid than it does as a solid. That's considered a physical change. So there we have it. What about the magnesium? Ooh, the ice is really cold too. What about the magnesium? What could I do to the magnesium and change it, but still remain magnesium? Well, let's think about that. I could take out a pair of scissors and cut the magnesium into smaller pieces, so I would have changed its appearance. Instead of one long strip of magnesium, I would have several strips of magnesium. So let's actually do that. So here I have a scissors and I'm cutting the pieces. And now I still have magnesium, but it looks different because I have four pieces instead of one piece, and each piece is now smaller than the original piece, but it's still all pieces of magnesium. So the physical appearance or a physical property has changed, but I haven't changed the chemical identity of the material. I still have magnesium. I may have changed its shape. I'm changed its individual mass of this or the individual volume of each of these, but I didn't change that it's still magnesium. So what I did here was I have a physical change, both with the ice turning into liquid water and the magnesium turning into smaller pieces of magnesium. In both cases, the chemical composition was the same. So what's a chemical property? Well, that's any property that describes the way a sample or matter may change, but this time the change has to alter the chemical composition of the matter. So I need to have a new substance when I'm done. What we observed before, I ended up still with H2O and Mg, still water, still magnesium. So what is a chemical property of water and what is a chemical property of magnesium? Well, I have to be able to describe how it's going to change or react. Well, what could I do to them to get a new substance? Well, I could take the magnesium, and you might know that metals react with acid. So I could react the acid with the metal, and I could get a brand new substance. So what new substances would I get? Well, it would depend on the acid I put in here. If I used hydrochloric acid, I would get magnesium chloride and hydrogen gas. So different substances than what I started with. So that would be a chemical property for magnesium. It reacts with an acid. What about H2O? What's a chemical property of H2O? Well, you may or may not know this, but H2O can react with an electric current, and you can separate the hydrogen from the oxygen and turn it into hydrogen gas and oxygen gas. And we'll actually do this demo later on in the year, and we will do what we call electrolysis. So magnesium reacts with an acid, water reacts with an electric current, and in both cases you get brand new materials. You get hydrogen and oxygen for the H2O, and you get hydrogen gas and magnesium chloride for the magnesium. So that was a chemical property. We described how they reacted, and we got new substances for both descriptions. So if I want to see a chemical property, it has to undergo a chemical change. Because I can't see that this is going to react with acid, the magnesium, unless I actually react it with acid. So what is a chemical change? A chemical change is any change in which the chemical composition of the material is altered and a new substance is formed. So let's go back to our examples again. Here I have the magnesium and here I have the water. I'm only going to show the reaction of the magnesium here with the acid. So I'm going to react it with 1 molar hydrochloric acid. I'm going to squirt it on these samples. Oh, watch carefully. I'm going to squirt some more. See if you can see the bubbles form. That bubbles represents the hydrogen gas being formed. You can see it right there. You get the hydrogen gas, and it kind of moves around. I'm going to do it a few more times. It's kind of fun. So the chemical composition is changing. It's not magnesium anymore. It's turning into hydrogen gas and magnesium chloride with the addition of hydrogen chloride, which we call hydrochloric acid. So as I shake it around, you can kind of see the bubbling that's going around on the edges. That's the formation of the hydrogen gas. So look kind of carefully, and you can see the bubbling right around this piece of magnesium. That is an indication that a gas is being formed. And so we have a chemical reaction or a chemical change because I have new substances that I didn't have before. So instead of just having magnesium, now I have magnesium and hydrochloric acid is going to become magnesium chloride and hydrogen gas. So there's an example of a chemical change going on. So what are the evidences? How do I know that a chemical change actually occurred? How do I see that a new substance is being formed? Well, here are some clues, or what we call evidence of a chemical change. And so we can have results that are not conclusive. So because you get bubbling sometimes, that doesn't mean you always have a chemical change. You can boil water and you can see bubbling, and that's not a chemical change because you just are making water vapor. So these are clues, but you need a little more information sometimes. So what are the clues? Well, you can have a change in odor. So if you get a new smell, that's a clue. So we will have chemical reactions in class where all of a sudden, oh, it smells like ammonia or something, and you know you have a new chemical. You can get an unexpected color change. What do I mean by unexpected? Well, if you take two clear solutions, you would expect it to become clear. But if it turns yellow, that's unexpected. What's not an unexpected color change? Well, that's if you take blue and red and it becomes purple. That's expected. You should know that from art. So it has to do something that is unexpected color change. You can also have a change in temperature or energy. So if the material is getting hot and you're not putting it on a hot plate, or it's getting cool and you didn't put it in the refrigerator, or it gives off light, it's doing something unusual, that's another clue that a chemical change might be taking place. You can also have the formation of a gas, which we just did with our last reaction. That bubbling we saw was the hydrogen gas being formed. And the last clue here that we have listed is the formation of a precipitate, which is kind of a long word that means solid particles. And you can see that because the solution may become cloudy, or you can actually see chunks. So if you mix some transparent solutions together and it becomes cloudy, or you can see chunks, you've made a solid, and that's a new material. So there we have it, some clues for chemical change. So we have physical properties, physical changes, and chemical changes. So hope you enjoyed this lesson. Thanks for listening.